The European storm in September 1939, when German Panzers rolled across the Polish border, most Americans watched from across an ocean that felt impossibly wide. The Great War, what we now call World War, had ended just 21 years earlier, and the scars still ached. America had no appetite for another European conflict. Isolationism wasn't just policy. It was a national mood, a collective exhaustion with the old world's endless quarrels. But President Franklin Delano Roosevelt saw something others missed. As France fell in a stunning 6 weeks during the summer of 1940, as the Luftwaffe darkened British skies during the Blitz, as U-boats prowled the Atlantic hunting convoys, Roosevelt understood that geography alone couldn't protect America forever. If Britain fell, if the entire industrial capacity of Europe came under Nazi control, the Atlantic wouldn't remain a barrier. It would become a highway for invasion. Yet Roosevelt faced a profound challenge. His nation was unprepared for modern war on an almost comical scale. The United States Army ranked 18th in the world in 1939, behind Portugal and barely ahead of Romania. Equipment was outdated, ammunition scarce, training minimal. The industrial base that had made America wealthy produced consumer goods, cars, refrigerators, radios, not weapons of war. And the American people? They wanted nothing to do with Europe's problems. The Neutrality Acts and their constraints through the 1930s, Congress had passed a series of Neutrality Acts designed to prevent American involvement in foreign wars. These laws prohibited selling arms to belligerents, restricted loans to warring nations, and forbade American ships from entering combat zones. The legislation reflected widespread belief that bankers and arms manufacturers had manipulated America into World War I for profit. For profits, a conspiracy theory that gripped the national imagination during the Depression. Roosevelt chafed under these restrictions. He watched Britain stand alone against Hitler and knew that if the British fell, America would face a Nazi-dominated Europe and an aggressive Japan in the Pacific simultaneously. The strategic situation would become untenable, so he began to maneuver. In September 1940, through a creative executive agreement that bypassed congressional approval, Roosevelt traded 50 aging American destroyers to Britain in exchange for 99-year leases on British bases in the Western Hemisphere. It was a legal fiction, calling it a trade rather than aid, but it provided Churchill with desperately needed vessels to fight the Battle of the Atlantic. Then came the presidential election of 1940. Roosevelt broke the two-term tradition to run for a third term, arguing that changing leadership during the global crisis would be dangerous. His opponent, Wendell Willkie, actually agreed with Roosevelt on foreign policy, but couldn't say so publicly, without alienating isolationist voters. The result was a strange campaign where both candidates promised to keep America out of war, while both privately believed involvement was inevitable. Roosevelt won and immediately pushed his most ambitious plan yet. Lend-Lease. Lend-Lease. The Arsenal Awakens announced in December 1940 and signed into law in March 1941. The Lend-Lease Act fundamentally transformed America's role in the war. Roosevelt sold it to the American public with a homespun metaphor. If your neighbor's house is on fire, you don't haggle over selling him a garden hose. You lend it to him, and he returns it when the fire is out. In practice, Lend-Lease meant the United States would manufacture weapons, vehicles, food, and raw materials and lend them to Britain, China, and later the Soviet Union. It was a legal fiction on a massive scale. Everyone understood most of the material would be destroyed or consumed and never returned, but it allowed America to support the Allies without formally entering the war. The program scale eventually became staggering, $50. $1 billion in aid, equivalent to roughly $800 billion today, including 400,000 trucks and Jeeps, 12,000 armored vehicles, 11,000 aircraft, 1.75 million tons of food, entire factories shipped in pieces and reassembled in the Soviet Union, but in early 1941. America faced a critical problem. It didn't have the industrial capacity to fulfill these promises while also rearming itself. The factories, the workers, the systems, none of it existed yet. It would have to be built from scratch while time was running out. Detroit's transformation begins in May 1940. Roosevelt called for the production of 50,000 aircraft per year. Military and industry leaders thought he'd lost his mind. America had produced fewer than 3,000 military aircraft in 1939. The president was calling for a 17-fold increase. William Knudsen, president of General Motors, was pulled from private industry and made a $1 a year man in Washington, an executive working for the government at token salary. His mission, convert American industry to war production. Knudsen knew automobiles. Now he would apply that knowledge to tanks and planes. The automobile industry seemed like a natural fit for weapons production. Already had massive production capacity, skilled workers familiar with metalworking and assembly supply chains for steel, rubber, glass and electronics engineering expertise in internal combustion engines, but the transition proved far more complex than anyone anticipated. Building a tank wasn't like building a car. Military specifications demanded precision and durability that civilian products didn't require. A car that failed after 50,000 miles was acceptable. A tank that failed in combat got soldiers killed. The early results were discouraging. Factories struggled to read military blueprints, which were far more complex than automotive designs. The tolerances were tighter, the testing requirements more rigorous, and the military itself kept changing specifications, seeking perfection in every detail. Knudsen and his team realized they needed to do something radical. They needed to redesign weapons themselves, making them more suitable for mass production, even if that meant sacrificing some performance. This philosophy would become America's secret advantage, the willingness to accept good enough in massive quantities rather than demanding perfection in limited numbers. The Chrysler tank arsenal in September 1940, the US Army approached Chrysler Corporation with an urgent request: build a facility capable of producing 1,000 tanks per month. This was an audacious number. Germany's entire tank production in 1940 was roughly 2,200 vehicles. Chrysler's president, K.T. Keller, accepted the challenge. But where could such a factory be built? It would need to be enormous, larger than any automotive plant in existence, and it would need to be built quickly. The solution was a bare field in Warren Township, Michigan, just outside Detroit. On September 9, 1940, groundbreaking began on what would become the Detroit Tank Arsenal. The construction timeline was aggressive, operational in 6 months. Architects worked around the clock designing a facility that would incorporate every lesson of modern mass production. The building would be 1,500 feet long and nearly 400 feet wide, so large it created its own weather system inside, with fog forming on cold mornings. Multiple rail lines would run directly into the factory, allowing raw materials to be delivered to the exact point they were needed. The assembly line would run the entire length of the building. At one end, raw steel plates would arrive. At the other, finished tanks would roll out, fully armed and fueled, ready for shipping. Everything in between would be choreographed like a ballet, each station performing its precise function as the vehicles moved down the line. And it would all need to work perfectly, immediately, because there was no time for trial and error. The Germans were winning. Labor questions who would work in these new war factories. America in 1940 still hadn't fully recovered from the Great Depression. Unemployment remained high, around 15%, which meant labor was available. But converting unemployed farmhands and Depression-era drifters into skilled industrial workers would require training on an unprecedented scale. The government and industry launched massive vocational training programs. High schools added evening courses in welding, metalworking, and blueprint reading. Community colleges ran accelerated programs. Factories established their own training centers, often right inside the plants, where new workers learned on actual equipment. A typical training program for an aircraft riveter took 6 weeks. Students learned to identify different rivet types, use pneumatic rivet guns, check their work for defects, and maintain speed without sacrificing quality. The best students could place 500 rivets per day with 99% accuracy. But this raised a more profound question: would America have enough workers? The answer, it turned out, required shattering social barriers that had stood for generations. Rosie the Riveter and the female workforce before Pearl Harbor, Only about 25% of American women worked outside the home, and those who did typically held jobs in traditionally feminine fields: teachers, nurses, secretaries, retail clerks. Heavy industrial work was considered inappropriate for women, physically too demanding, and culturally unacceptable. The war changed everything. As men enlisted or were drafted into military service, factories faced catastrophic labor shortages. The response was a massive government propaganda campaign encouraging women to take industrial jobs. Rosie the Riveter, the iconic figure in a polka dot bandana flexing her bicep, became the symbol of female industrial workers. The propaganda worked, perhaps too well. By 1944, women made up 35% of the civilian workforce, with nearly 20 million women employed. In aircraft factories, the percentage was even higher, sometimes exceeding 60% of the workforce. These weren't token positions or simple tasks. Women became welders, riveters, crane operators, and inspectors. They read complex blueprints, operated dangerous machinery, worked in deafening noise and choking fumes. At the Boeing plant in Seattle, women assembled entire B-17 bomber fuselages. At the Willow Run factory in Michigan, women worked on every aspect of B-24 Liberator production. The women themselves often expressed surprise at their own capabilities. One riveter interviewed decades later recalled, "I didn't know I could do it. Nobody told me I could. But when they showed me how, I thought, well, this isn't so hard. And then I got good at it. Really good. I could out-rivet most of the men." The social implications were profound. Women discovered economic independence. They proved to themselves and to skeptical men that the supposed physical and mental limitations of their gender were largely fiction. When the war ended, government and industry expected women to return home voluntarily. Many did, but many did not, and their wartime experience planted seeds for the feminist movements of the 1960s and beyond. The race question America's racial dynamics complicated industrial mobilization. In 1940, the United States military was strictly segregated, with black Americans restricted to service roles or black units under white officers. In civilian industry, discrimination was rampant, with many factories refusing to hire black workers for skilled positions regardless of qualification. This was both morally indefensible and strategically stupid. America couldn't afford to leave millions of potential workers on the sidelines while claiming to fight for democracy and freedom. Philip Randolph, president of the Brotherhood of Sleeping Car Porters, the first predominantly black labor union, organized a march on Washington scheduled for July 1 to 1941, demanding equal access to defense industry jobs. Roosevelt, fearing both the optics and the potential for violence, negotiated with Randolph. The result was Executive Order 8802, which banned racial discrimination in the defense industry and federal government. The order's enforcement was inconsistent and often ignored, but it represented a federal commitment that hadn't existed before. Black Americans migrated north and west to defense industry jobs, particularly in shipyards and aircraft plants. The Great Migration that had begun during World War I accelerated dramatically. In defense plants, black workers proved just as capable as white workers, a fact that some white workers and managers found threatening. Hate strikes occurred at several factories when black workers were hired or promoted. The most serious occurred at the Packard plant in Detroit in 1943, when 25,000 white workers walked off the job to protest the promotion of 3 black workers. Federal troops were required to restore order. Despite the obstacles, black Americans made significant contributions to war production, and their wartime experiences, particularly military service overseas, where they often encountered less racism than at home, planted seeds for the civil rights movement that would emerge in the 1950s. December 7, 1941. The awakening complete the Japanese attack on Pearl Harbor changed everything in a single morning. The isolationist movement collapsed instantly. America was at war, fully committed, with an aroused and unified population. The attack destroyed or damaged 8 battleships, 3 cruisers, 3 destroyers, and nearly 200 aircraft. Over 2,400 Americans died. It seemed like a catastrophic defeat, But Admiral Yamamoto, who had planned the attack, understood its limitations. Japan had struck the Pacific Fleet's battleships but missed the aircraft carriers, which were at sea. More importantly, the attack hadn't touched America's industrial capacity. The factories, the workers, the raw materials, all remained intact, 3,000 miles from Japanese reach. Yamamoto reportedly said, though the quote's authenticity is disputed, "I fear all we have done is to awaken a sleeping giant and fill him with a terrible resolve." Whether he said it or not, the sentiment was accurate. America had been awakening slowly since 1940. Pearl Harbor completed the process instantly. Now there would be no constraints, no half measures, no debates about neutrality. The entire nation would mobilize for total war. And the scale of that mobilization would exceed anything the world had ever seen. Part 2. The Mobilization, 1942. The production miracle begins in January 1942. Roosevelt announced production goals that made his 1940 aircraft target seem timid. 60,000 aircraft in 1942, 125,000 in 1943, 45,000 tanks in 1942, 75,000 in 1943, 8 million tons of shipping in 1942, 10 million in 1943. Military and industry leaders were skeptical. Some thought the numbers were propaganda meant to intimidate the Axis. Others worried Roosevelt had overreached. That failure to meet these goals would be a propaganda disaster. They didn't understand what was about to happen. America wasn't just going to increase production, it was going to reinvent how production worked. The War Production Board in January 1942, Roosevelt created the War Production Board, or WPB, and appointed Donald Nelson as its chairman. The WPB had extraordinary powers. It could mandate what factories produced, allocate raw materials, control prices, and direct the entire American economy toward military production. This was economic control that would have been unthinkable in peacetime, bordering on socialism. The government essentially took command of private industry. But with the nation at war and Pearl Harbor still smoking in memory, there was virtually no resistance. The WPB immediately halted civilian automobile production. No new cars would be built until the war ended. Factories that had produced Chevrolets and Fords would now produce trucks, tanks, and aircraft engines. Rubber, critical for tires, was diverted entirely to military use. Americans were asked to turn in scrap rubber, with children collecting old tires and garden hoses for recycling. Similar restrictions hit consumer goods across the board. New refrigerators, radios, and washing machines became unavailable. Clothing manufacturers faced restrictions on fabric and designs. No more cuffs on trousers, limited pleats and skirts to save material. Butter, sugar, meat, coffee, and gasoline were rationed. Americans accepted these privations with remarkable unity. Rationing was seen as a shared sacrifice, a way for those on the home front to contribute to the war effort. Black market activity existed, but was relatively minor and socially stigmatized. The Liberty Ship Revolution, America's first production miracle, came not in aircraft or tanks, but in cargo ships. Britain was losing the Battle of the Atlantic. German U-boats were sinking merchant vessels faster than Britain could replace them, threatening to starve the island nation into submission and cut off Lend-Lease supplies. The solution was the Liberty Ship, a simple, standardized cargo vessel designed for rapid mass production. The design wasn't revolutionary. It was based on a 1930s British tramp steamer, but the construction method was. Traditional shipbuilding involved constructing vessels on site in dry docks, with workers fabricating each piece as needed. It was skilled craftsmanship that took 6 months to a year per ship. American shipbuilder Henry Kaiser revolutionized the process. Instead of building ships from the keel up in a single dry dock, Kaiser's shipyards built ships in prefabricated sections. Workers in workshops away from the water would construct entire hull sections, deck houses, and engine rooms. These massive pieces, some weighing 50 tons, would then be brought to the slipway and welded together. The method borrowed from assembly line manufacturing. Instead of shipwrights performing every task, workers specialized. One team welded hull plates. Another installed electrical systems, a third fitted engines. Each team perfected their specific task and moved from ship to ship to ship to ship. the results were extraordinary. The first Liberty ship, the SS Patrick Henry, launched in September 1941 and took 244 days to build. Within a year, Kaiser's Richmond shipyard was launching a Liberty ship every 30 days. By late 1942, the average was 2 weeks. The record was set in November 1942 when the SS Robert E. Peary was constructed in 4 days, 15 hours and 30 minutes from Keel Lane to launch. It was a publicity stunt. The ship wasn't fully operational and required additional fitting, but it demonstrated what coordinated mass production could achieve. By the war's end, America had built 27 10 Liberty ships. They weren't elegant. Sailors called them ugly ducklings. They were slow, uncomfortable, and prone to cracking in cold water. But they worked. They carried millions of tons of cargo across oceans where U-boats prowled, and when submarines sank them, 3 more launched the same week. The Germans never had a chance. They sank 200 Liberty ships during the war, a tragic loss of life and material, but America built them faster than U-boats could sink them. By 1943, Allied shipping tonnage was increasing despite German attacks. The Battle of the Atlantic turned, not because the Allies defeated every U-boat, but because they simply outproduced the destruction. Willow Run, the bomber factory while shipyards performed miracles, the aircraft industry faced even greater challenges. Roosevelt wanted 125,000 planes in 1943, an impossible number by traditional aircraft manufacturing methods. Building an airplane in 1940 was closer to art than industry. Aircraft were hand-assembled by skilled craftsmen who fabricated pieces individually, filed parts to make them fit, and used instinct and experience to solve problems. 2 supposedly identical aircraft often had hundreds of small differences. This artisanal approach couldn't produce 125,000 planes. Henry Ford, now in his late 70s but still sharp, believed the solution was applying automobile assembly line techniques to aircraft. In 1941, his Ford Motor Company broke ground on a factory at Willow Run, Michigan, to build B-24 Liberator bombers under license from Consolidated Aircraft. The factory was the largest single building in the world, 3.5 million square feet under one roof, half a mile long and a quarter mile wide. When workers entered through one door and walked to their station, some needed 15 minutes just to reach their workplace. The assembly line ran the length of the building. At one end, raw aluminum sheets arrived. At the other, finished B-24s, 4-engine, heavy bombers weighing 36,000 pounds empty, rolled out at peak production rates of 1 per hour. But achieving that rate took longer than expected. The B-24 was complex. 1.5 million parts, 150,000 rivets, miles of wiring. Ford engineers struggled to adapt automotive mass production techniques. The Army kept changing specifications. Workers needed extensive training. Production bottlenecks appeared in unexpected places. Charles Lindbergh, the famous aviator, visited Willow Run in 1942 and was skeptical. He wrote in his diary that Ford was trying to mass-produce what shouldn't be mass-produced, that bombers required craftsmanship that assembly lines couldn't provide. He was wrong. By 1943, Willow Run's teething problems were solved. The factory hit its stride, producing 1 B-24 every 63 minutes. Workers, many of them women, became so skilled that quality increased while production accelerated. By war's end, Willow Run had produced 8,685 B-24s, more than half of all Liberators built. Similar transformations occurred at Boeing B-17 Flying Fortresses, Douglas C-47 transports, and Republic P-47 Thunderbolt fighters. American aircraft production went from 5,865 in 1939 to 96,318 in 1944. That single year's production exceeded Germany and Japan's combined output for the entire war. The tank production proved more difficult than ships or aircraft. Tanks required precision engineering, thick armor plate, complex transmissions, specialized cannons, and intricate track systems. Everything was heavy, difficult to machine, and had to withstand battlefield stress that would destroy civilian vehicles. Early American tank designs were disastrous. The M3 Lee Grant medium tank rushed into production in 1941. was tall, ungainly, with a limited traverse main gun mounted in a hull sponson. It was obsolete before it entered production, but was built anyway because America desperately needed tanks and had nothing better. The M4 Sherman, introduced in 1942, was a massive improvement. Designed from the start for mass production, the Sherman used a cast hull front, easier to produce than welded plates, a radial aircraft engine already in mass production for other uses, standardized bogie suspension, identical component, easy to repair, a gyro stabilizer for the main gun, primitive but effective. The Sherman wasn't perfect. Its armor was thinner than German tanks. Its 75 mm gun was adequate against most targets, but struggled against heavy German armor. It was prone to catching fire when penetrated. German tankers called it the Tommy Cooker, and Americans called it the Ronson, after a lighter that advertised lights every time. But the Sherman was reliable, easy to maintain, and could be produced in enormous quantities. Chrysler's Detroit tank arsenal hit full stride in 1943, producing 2,000 Shermans per month. Fisher Body, Pressed Steel Car Company, Lima Locomotive Works, and Pacific Car and Foundry also mass-produced Shermans. By war's end, America had produced 49,234 Sherman tanks in all variants. Germany produced 1,347 Tiger tanks and about 6,000 Panther tanks total. When a Sherman encountered a Tiger or Panther, it was at a severe disadvantage. German tanks had thicker armor and more powerful guns. But American forces never encountered German tanks in equal numbers. They encountered them in ratios of 10 or 20 to 1. There's a persistent myth that American tank doctrine was to swarm German tanks with Shermans, accepting 3 or 4 losses to destroy each enemy tank. This wasn't doctrine. It was simply reality. American tanks were adequate, available everywhere, and replaceable. German tanks were superior but scarce. American tankers developed tactics to compensate. They used superior numbers, better communications, air support, and combined arms coordination. Most importantly, when a Sherman was destroyed, another arrived within days. When a Tiger was destroyed, replacement might never come. The arsenal's supply chain production numbers tell only part of the story. Behind every tank, ship, and aircraft stood an invisible miracle, the supply chain. Consider a B-24 Liberator bomber. It contained aluminum from Alcoa smelters in Tennessee and Washington steel, from Pittsburgh Mills rubber, from plantations in Liberia electronics, from RCA in New Jersey plexiglass, from Roman Haas in Philadelphia fabric for control surfaces, from textile mills in North Carolina instruments, from multiple specialized manufacturers' engines, from Ford in Michigan, propellers from Curtiss in Ohio. All of these components had to arrive at Willow Run in precisely coordinated sequence. Too much inventory cluttered the factory floor and tied up capital. Too little caused production stoppages. The timing had to be perfect. This required unprecedented logistics coordination. The War Production Board tracked thousands of materials across hundreds of suppliers. Railroads were given priority scheduling for war materials. Trucks moved in convoys to ensure delivery. The United States essentially invented modern supply chain management during World War II. The scale is difficult to comprehend. America consumed 75 million tons of steel annually, 2 billion board feet of lumber, 44 billion pounds of aluminum raw materials from every continent, and somehow, miraculously, it all arrived when needed, in the quantities needed. Raw material challenges, some critical materials weren't available domestically, creating vulnerabilities. Rubber was the most serious. Before Pearl Harbor, 90% of America's rubber came from Southeast Asia, now under Japanese control. The rubber shortage threatened to cripple military production and civilian life. Vehicles needed tires, aircraft needed tires, hoses, and gaskets. Ships needed rubber fitting. Soldiers needed rubber boots. The government responded with multiple initiatives. Mandatory rubber rationing and scrap drives development of synthetic rubber, a program that ultimately cost $700 million. Expansion of rubber plantations in Liberia, strict limits on civilian tire use. By 1944, America was producing 800 0 tons of synthetic rubber annually. More than total natural rubber consumption before the war, it was a triumph of chemistry and industrial scale. Similar challenges affected other materials. Tungsten for armor-piercing shells came largely from China. Chromium for hardened steel came from Turkey and Africa. Tin came from South America. Each required diplomatic arrangements, shipping coordination, and strategic planning. The United States managed all of this while also supplying allies. Britain, the Soviet Union, and China received massive quantities of raw materials through Lend-Lease. America essentially became the arsenal for the entire Allied war effort. The workforce expansion by 1943, American factories employed 17 million workers directly in war production, with millions more in supporting roles. Unemployment, 15% in 1940, had effectively disappeared. The challenge now was labour shortage. Factories recruited aggressively, often sending representatives to small towns to recruit workers who'd never left home. Promised were high wages, steady work, and contribution to the war effort. Workers poured into industrial cities. Detroit, Seattle, Los Angeles, Portland, creating housing crises and straining public services. Government and industry built entire communities for defense. The city of Richmond, California grew from 23,000 people in 1940 to 100,000 by 1943, mostly shipyard workers. Housing developments appeared overnight. Bare-bones apartments and dormitories built by the government and rented at controlled rates. The 24-hour factory became standard. 3 8-hour shifts meant production never stopped. Workers walked in as others walked out. The factory floor was in constant motion. The machinery never sleeps became a point of pride. Safety often took a backseat to production. Industrial accidents were common. Fingers crushed in presses, burns from welding, falls from scaffolding. The culture emphasized toughness and perseverance. Workers who took sick days or complained about conditions were seen as undermining the war effort. Labour unions, which had fought bitter battles for better conditions through the 1930s, pledged not to strike during wartime. The no-strike pledge held reasonably well, though there were exceptions, notably the United Mine Workers strikes in 1943, which drew harsh public condemnation. Wages were controlled to prevent inflation, but workers still saw their incomes rise substantially. The poverty and deprivation of the Depression years gave way to steady paychecks, full employment, and a sense of contributing to something larger than themselves. The cost of production all this industrial miracle required financing on a scale never attempted. The US federal budget exploded. 1940, $9.05 billion, 1945. $92.07 billion, where did the money come from? Taxes increased substantially. The top marginal tax rate reached 94% on income over $200,000. But taxation alone couldn't cover war costs. The government borrowed massively through war bonds. War bond drives became social events. Movie stars sold bonds at rallies. Schools held competitions to see which classes could sell the most. Buying bonds was patriotic duty. By war's end, 85 million Americans, more than half the population, had purchased bonds. Total war expenditure reached $296 billion, roughly $4.07 trillion in 2024 dollars. It was financed through individual income taxes, 43% corporate taxes, 33% borrowed money, bonds, 24% the debt concerned some economists, but the Roosevelt administration argued correctly that the economy's massive expansion would make the debt manageable post-war. They were right. Post-war economic growth allowed the debt to be paid down relatively painlessly. The innovation machine mass production alone wouldn't have won the war. America also innovated constantly, improving designs and developing new technologies. The proximity fuse, a miniature radar in an artillery shell that detonated near aircraft rather than requiring direct hits, was called by Eisenhower one of the 3 most important Allied technologies, along with the atomic bomb and the Jeep. Development required breakthrough work in miniaturization and rugged electronics. Radar went from laboratory curiosity to production weapon, with sets installed on ships, aircraft, and ground stations. By 1944, American factories were producing radar sets by the thousands, each one a complex collection of vacuum tubes, antennas, and displays. The Manhattan Project, developing the atomic bomb, was the largest scientific program in history, employing 130,000 people and costing $2 billion, $30 billion in 2024 dollars. While the bomb itself saw limited use, the project drove advances in physics, chemistry, and industrial processes that had lasting peacetime applications. Penicillin mass production was perfected during the war. Before 1942, penicillin was rare and expensive. By 1945, American pharmaceutical companies were producing 650 billion units per month, enough to treat every wounded Allied soldier. This single innovation saved hundreds of thousands of lives. Even mundane improvements mattered. Better welding techniques, improved alloys, more efficient machine tools. These incremental advances multiplied across millions of units meant enormous aggregate improvements in quality and production speed. Comparing production, America versus Germany, 1942-1943. By 1943, the production gap between America and Germany was staggering. Aircraft, 1943. United States, 85,998. Germany, 24,807 tanks, 1943. United States, 29,700 artillery, 1947. 38,000. Zero trucks and vehicles, 1943. United States, 650,000. Germany, 80,000. These numbers tell the story. Germany was still producing weapons in substantial quantities, but America had achieved production superiority in every category. More importantly, America was accelerating while Germany was approaching its production ceiling. Germany had mobilized nearly every factory, conscripted almost every available worker, and extracted as much from its economy as possible. America was still ramping up. Part 3. The German Perspective, 1943-1944. The view from Berlin in 1943, German military and political leaders faced an uncomfortable truth. They were being outproduced by an enemy whose factories they couldn't reach. Hitler had believed, and many Germans shared this belief, that democracies were weak, decadent, and incapable of sustaining total war. Americans in Nazi propaganda were portrayed as soft, spoiled by luxury, divided by racial conflict, and lacking the martial spirit necessary for victory. The reality was devastating, that propaganda narrative. America had mobilized with speed and completeness that surpassed Germany's own efforts. Worse, American industrial capacity seemed limitless. Every intelligence report brought worse news. More factories, more production, more weapons, more weapons. Albert Speer, appointed Minister of Armaments in February 1942, understood the mathematics of attrition. In his memoirs, written after the war, he described the moment he realized Germany would lose. I could see it in the production figures. We were fighting not just the Red Army, but Detroit and Pittsburgh, and those were battles we had already lost. German production strengths and constraints. Germany wasn't industrially backward. Before the war, it was Europe's industrial powerhouse with world-leading capabilities in chemicals, precision machinery, optics, and heavy industry. But Germany faced constraints America didn't. Resource scarcity. Germany lacked adequate petroleum, rubber, aluminum, and other critical materials. Romanian oil provided some supply, but never enough. Synthetic fuel production required enormous effort. Rubber remained chronically short. Territory under attack. By 1943, Allied bombers were hitting German cities. Factories were targets. American factories faced no such threat. They operated undisturbed 3,000 miles from enemy bombers. Labor shortage. Germany had fully mobilized its workforce early in the war. Additional production required using forced labor, slaves from occupied territories and concentration camps, who were poorly fed, poorly trained, and had no motivation to produce quality work. Transportation bottlenecks. Germany's rail system was overburdened and under constant attack. Moving raw materials to factories and finished weapons to the front became increasingly difficult. Strategic confusion. Hitler constantly intervened in production decisions, demanding new wonder weapons while starving existing programs of resources. Designs were changed mid-production. Priorities shifted. The result was chaos. The philosophy of Wunderwaffe in German culture emphasized engineering excellence. The best tank, the best aircraft, the best gun, these were points of national pride. German weapons were marvels of engineering, precisely machined, beautifully designed, incorporating cutting-edge technology. The Tiger tank epitomized this approach. Introduced in 1942, it was the most powerful tank in the world. 88-ton gun that could destroy any Allied tank at long-range armor, thick enough to resist most Allied weapons, advanced optics for accurate gunnery. German tankers who transferred from older tanks to Tigers felt invincible. Allied tankers learned to fear the Tiger's distinctive boxy shape. But the Tiger was horrifically complex. Required 300,000 man-hours to build, used a Maybach HL 230-45 engine, requiring precision manufacturing, had interleaved road wheels that clogged with mud and froze in winter, consumed fuel voraciously. 3 gallons per mile, required constant maintenance by skilled mechanics. Germany produced roughly 1347 Tigers total during the war. They were formidable weapons, but there were never enough of them. A Tiger company typically had 9 tanks operational, with the rest undergoing repairs. This pattern repeated across German weapons development. The Me-262 jet fighter, revolutionary technology but produced too late and in insufficient numbers. 1430 built the V-2 rocket. Impressive engineering, but the program consumed resources that could have built 24. Zero fighters. The Panther tank, arguably the best tank of the war,